Welcome to RAD's IPmux troubleshooting demo. This demo will walk you through the basic steps required to troubleshoot an IPmux application. The IPmux provides powerful performance monitoring tools at three different levels. The TDM statistics monitors the status of the physical T1 parameters. At the Ethernet level, you can monitor the Ethernet connection status, including the speed, duplex, and traffic statistics. At the pseudowire level, you can track the pseudowire bundle connection status on the packet switch network. To access the performance monitoring tools, please select Monitoring from the main menu of the IPmux to view the different options. The following instructions are based on an IPmux point-to-point application over a Layer 3 routed network or a Layer 2 switch network. We will begin our troubleshooting demo at the pseudowire level. At default, with no configuration, the bundle connection status shows empty. If properly configured and under ideal network conditions, the bundle connectivity status should show OK, with no sequence or jitter buffer errors. Please refer to RAD's IPmux configuration demo for instructions on how to configure the IPmux. If the pseudowire bundle is disabled, the connectivity status indicates this. If the connectivity status shows unavailable, it could be an indication of an issue at the IP layer or a mismatch in the configured bundle ID. To troubleshoot this, the first step is to verify that the next hop MAC address is displayed. If it's not, try to ping the destination IP or the default gateway if connecting across a Layer 3 routed network. If the IPmux doesn't learn the MAC address, the issue is isolated at the physical Ethernet layer. If the next hop MAC address field is populated and you can ping the destination IP of the remote IPmux, then verify that the destination bundle ID is properly configured on peer IPmux units. If the destination bundle ID is correct, verify that UDP port number 2142 is not blocked on your IP network. The IPmux always uses UDP port 2142 as the destination UDP port for TDM over IP traffic. When the bundle connectivity status shows a validation failed message, it indicates that there is a mismatch in the configuration between peer IPmux units. This status message is only displayed when OAM mode is enabled in the bundle configuration. Possible causes of a validation fail error message include a mismatch in the number of configured time slots per bundle when using a fractional T1, or a mismatch in the signaling mode for the T1 assigned to the bundle. A bundle connectivity status showing local fail indicates that the IPmux is now receiving pseudowire packets for the configured bundle. Suppressing the transmission of out-of-service packets, OOS, in one direction only can cause the bundle to be in local fail. The configured OOS mode must match on peer IPmux units. Bundle connectivity status showing remote fail indicates that the local IPmux is receiving pseudowire packets, but the remote IPmux is in a local fail status. At the Ethernet level, under ideal conditions, the speed should show up as 10, 100, or 1000 megabits full duplex depending on the auto negotiation setting or the hard-coded speed. Half duplex mode of operation will cause collisions at the Ethernet layer and errors at the pseudowire bundle level. If the duplex mode is not full, check the physical Ethernet port configuration to verify that the configured speed matches the connected equipment. As a rule of thumb, RAD recommends that you hard code the speed and duplex on the IPmux and the directly connected device. Also verify that the displayed status shows connected. The statistics of the Ethernet bridge should indicate increase in transmit and receive frames with no CRC errors or collisions. Dropped frames could indicate Layer 2 frames that are not processed by the IPmux. For example, spanning tree protocol, and layer 2 tunneling protocol frames. The number of dropped frames should be negligible in comparison to the transmit and receive frames. If the Ethernet bridge statistics shows unidirectional traffic in the transmit direction only, it indicates that the pseudo-wire bundle is most likely in a local fail status. Unidirectional traffic in the receive direction only points to the pseudo-wire bundle being in either an OK or remote fail status. When monitoring the TDM statistics, verify that there are no errors. If you notice an increasing loss of signal counter, LOS, on the T1, please check the physical T1 cable. In most scenarios, the IPmux requires a crossover T1 cable for connection to the end equipment. Each TDM over IP packet transmitted by the IPmux holds a sequence number. The remote IPmux checks these numbers and expects to see that every new incoming packet is in sequence relative to the previous one. When for some reason this doesn't happen, it indicates there has been a problem with the packet flow integrity, and the IPmux indicates this by increasing the sequence error counter by 1. Reasons for a sequence error notification include missing packets or packets arriving out of order due to queuing mechanisms or quality of service issues on the IP network. RAD's recommendations for mitigating sequence errors include ensuring that IPmux traffic has sufficient bandwidth guaranteed end-to-end along the traffic path, and ensuring that the IP network provides priority to the IPmux traffic. When troubleshooting sequence errors, check the Ethernet bridge statistics to verify that there are no collisions or increasing CRC errors. Also verify that quality of service is provisioned on your IP network, and if necessary, you can modify the TDM bytes in frame parameter under the bundle connection configuration to control the amount of bandwidth consumed by the IPmux. The IPmux is equipped with a jitter buffer responsible for compensating IP network delay variation. The jitter buffer is required in order to provide the TDM equipment with a synchronous and constant flow. If the buffer is gradually emptied until it's underflowed, we have a buffer starvation. Each underflow event increases the jitter buffer underflow counter by 1 and indicates a problem in the end-to-end voice integrity. Underflow events can be caused by buffer starvation, as we mentioned earlier, dropped packets, delayed packets due to network congestion, incorrect timing configuration, or a small jitter buffer size. To troubleshoot jitter buffer underflows, ensure that there are no sequence errors, and verify that the TDM transmit clock is properly configured on both IPmux units. For more information on the timing configuration, please reference RAD's IPmux configuration guide. You can also try increasing the jitter buffer size. A jitter buffer overflow is the opposite of an underflow. An overflow situation always results in an immediate underflow forced by the IPmux. Jitter buffer overflows can be triggered by a big burst of packets filling up the jitter buffer completely, insufficient jitter buffer size, or an incorrectly configured TDM clock. The same troubleshooting steps for the jitter buffer underflow event apply to the overflow scenario. This concludes our IPmux troubleshooting demo. Thanks for watching. If you have any questions, please feel free to contact us.